Okay. Hello, everyone. Hope you're well. Welcome to another edition of Math 1203. Had some technical difficulties there, but I think we're okay. Okay. There we go. So get this out of the way here. All right. So the plan for today is just to get through a bunch of examples. We have a lot of examples to get through, so we're just going to go through those. And just want to remind you again that we have a test coming up on the 18th, which is Thursday. And yeah, it'll somewhat be like a combination of all the quizzes that you've seen up to this point. But as well, I will maybe even post the test that I gave last semester, just as an example, for what you guys can practice going through, practice like uploading stuff and actually doing a test. So I'll give you, right after this, just set up the test on Gradescope that I gave last semester, same timing and everything, and you guys should be able to go through that. Should be very similar to what your test is. Also, homework is going to be due, so you need to do all the homework up to section 3.4, which I think is what we're doing right now is included in that. Yeah, and that being said, we're going to be doing all of these guys. So what have we been up to? We've been talking about derivative rules and formulas and properties, right? So constants factor outside of derivatives distribute across sums. We saw how to differentiate a general exponential function and the natural exponential function. We saw a very important rule called the chain rule. So when you have one function plugged inside another, the derivative of such a function is the derivative of the outer function, leaving the inside alone initially, and then multiplying by the derivative of the outer function. Did a few examples on that. We learned some other things as well. Let's see where we're. About how to generalize rules with the chain rule. So this is how you generalize the exponential rule and the general exponential rule. We looked at product rule, quotient rule. Where are those? We looked at the power rule, a very famous rule. We looked at how to prove that, and that's the power rule there. Shows you how to deal with the derivative of x to a power. We also looked at the product rule, which is the rule that is written here. If you have a derivative of a product, like functions f and g, derivative of the first one times the second plus the first times the derivative of the second, right? And we use that and the chain rule to derive what we call the quotient rule. And this is how to differentiate one function divided by another. And of course, these rules, I would only really use them if both functions are not constants, because we have the constant factor rule and things like that, so we wouldn't really need it otherwise. And then we got to these examples, so that's where we are. And of course, you should know all those rules and formulas, kind of have them memorized, and yeah, at the end of the day, that's what we're going to do. So that being said, we're going to jump into it. We are going to get through all of these, learn some lessons along the way, see what we can come away with here. So I think I wrote these as y equals x cubed e to the x. Okay. So this means y prime is going to be equal to, what do you think we need to use here?
Product rule.
Product rule. There are two functions multiplying each other. Boom, boom. That's like my f, that's like my g. So differentiate the first one, which we know by the power rule is 3x squared. Leave the second one alone. Plus, leave the first one alone. Differentiate the second one. Derivative of e to the x is e to the x. And so this is like f prime. This one is g. This is f. This one is g prime. And Yeah, that's pretty much it. I mean, you could, optional, do something like factor out an x squared e to the x, and you'd be left with 3 plus x if you wanted to. Yeah, but that's the answer. Dos. Y equals the square root of x, e to the x. Again, we have a product of functions. Now, pro tip, you're always going to want to rewrite. I'm not sure if I want that in red. Pro tip. Remember, the rules, formulas are your templates. You should rewrite when necessary. To apply to be able to apply a rule that you know. Now, what do I mean by that here is that we may know at this point that d dx of the radical of x is 1 over 2 radical x. But if we forgot, we should also know that d dx of x to the n is equal to n x to the n minus 1, and would rewrite this as d dx of x to the half, which is going to be 1/2 x to the minus a half, which is in fact 1 over 2 radical x. So that's just something. So here, the radical x is not that bad, but in general, I would rewrite radicals as powers. The radical x, so if not, maybe I should say, especially when we do not have a square root, we would rewrite radicals as powers. The idea is you want it to look like your rule before you start to apply anything. So you could do this. So it's going to be y prime equals differentiate the first one times the second plus leave the first one, differentiate the second. Directly by product rule, and the derivative of the radical x equals 1 over 2 rad x. Or if you have y equals rad x e to the x, then what you would do is you just say, hey, I'm going to rewrite this as that. So first rewrite. So this is going to come up especially later, so I just want to throw this out there. First rewrite, then you can actually now apply the derivative. By the product rule. So it's 1/2 x to the minus 1/2 e to the x plus x to the 1/2 e to the x. So this is apply product rule. No matter what, notice that there is some rule in the back of my mind whenever I'm doing anything, right? So either I'm applying the rule that I have memorized for the square root, or I'm applying the rule, the power rule. At any point, I do not do anything unless I can think of a rule that tells me it's okay to do that specific thing. So here I could rewrite this as, and I mean, this would be the answer, to be honest. But you could rewrite if you want. And doing this would be is better for general radicals. Okay. So I'm just going to do that. So if I had a cube root or a fifth root or a seventh root or something crazy like that, I'd rewrite it as a power first, to be honest. So and then just go through here. But a couple of ways you can get to that and get to that answer. So let's see here. What else do we have? Y equals 3x squared ln of x. Again, product rule, right? You have two functions multiplying each other. Right? So we, again, notice we have two non-constant functions multiplying each other. This means we want to use product rule. So we go in y prime, and I would look at the first one, and we know that we have the constant factor rule, so there's a 3 in front. I would ignore the 3, just leave the 3 alone, differentiate the x squared, which is 2x. So this is actually going to give me 6x times ln x. So that's my f prime, that's my g, plus now I have my 3x squared hanging out, multiplied by the derivative of ln x, which we have memorized is 1 over x. So this is my f, that's my g prime. I can simplify this a little bit, 6x ln x plus, well, 3x, that's going to be. Or I could factor out, say, a 3x, get that. Now, you don't always have to factor, especially if there's nothing like to cancel or simplifying, like there's no benefit to factoring. The only thing I would suggest is, well, if you're on a multiple choice situation, you should be able to recognize that these two things are the same. But like in general, I wouldn't say to factor without a reason. One good reason to factor is to simplify things, right? So if you have like a fraction or something, you would factor the top and the bottom to see if you can cancel anything and write it as a simpler fraction. Yeah, that's it. That was problem 3. Let's move to problem 4. Now, of course, I mean, if you have any questions while I'm going through these, you should stop me. But hopefully the theory is that you guys all try this already. I mean, you already had a quiz on some of this stuff, so you should have been practicing. So I can kind of go through this quickly, relatively speaking, and not really lose you guys. But if I do lose you with anything, I would do this. So here, we again have a product of functions. But you might be thinking product rule. Not so fast, like. So here comes in another pro tip for us that can be very useful in some situations, right? So just because you can use a rule doesn't always mean that you should. There are times when, even though you can use a product rule, you wouldn't want to use a product rule. For example, if I want to differentiate 5 times x cubed, I would not use the product rule. I would use a constant factor rule. The constant factor rule can deal with that much easier than the product rule, and I don't really have to worry about the derivative of 5 being 0 and me forgetting that, which happens all the time, believe it or not. And that can kind of mess you up. So here's the thing. Another pro tip. And this is going to come up later. Where is this going to come up? Yeah, in problem 19, this idea that I'm telling you right now is going to apply hard. So pro tip. So generally, we want to apply lower level rules before higher level ones. And that's not really just for calculus, that's kind of just math in general. I know a lot of people think of math as being difficult, or math people being more difficult than they need to be, but the actual truth is quite the opposite. Math people actually try to get away with the easiest thing that they can possibly get away with in the beginning. Like if something gets complicated, it's because it had to get complicated. We always try to look for a simpler rule. We always try to look at a complicated problem and try to use what we know about a simpler problem to solve that more complicated problem. Just like how when we had to face solving the rate problem, what did we do? We went back to literally finding the slope of a straight line. And hey, let's try to use this to solve that, right? You always want to try to think simpler. And what that applies, how that applies here is that, remember that your algebra rules would be lower level than your calculus rules. So for example, so if you can apply those first, you probably should. Now, sure, in this case, you're not going to get into too much trouble because it's a very simple example, but I'm not going to give you such a simple example on a test. So let's be real about that. And this even works when you are within a certain category. So for example, there were times when I would ask my pre-calc students, for example, to say factor, say x to the 6 minus y to the 6. And it turns out that there are 2 ways you can actually do this, 2 main ways that the average pre-calc student would actually be able to do this. One is they could write it as x cubed squared minus y cubed squared, apply the difference of squares first. You'll get into a situation where you can apply the difference of cubes, sum of cubes formula. Or another way to look at it is think of this as x squared cubed minus y squared cubed. and apply the difference of cubes formula. Now, it turns out the student who applies the difference of squares formula first will get to the final fully simplified answer a lot easier than the student who tries to apply the difference of cubes formula first. Even applying the difference of cubes formula first kind of puts you in a situation, puts you in a difficult situation actually. You'll get to a point where you think it can't factor anymore, but it actually can. And in order for you to see that, it's going to be very hard. And then even if you do see it, in order for you to actually perform it and do it, is going to be harder. You might have to like apply long division of polynomials or something like that. And those are probably the ways that a super good pre-calc student would actually see to do it. Whereas the student who goes in with the difference of squares formula first, because it's lower level, why apply a rule for cubes if I'm able to apply a rule for squares? And so the student who applies the rule for squares first will actually have a much easier time. It's much more like follow your nose kind of thing. So I don't know if I want to show you, it's not a pre-calc class. I mean, here you would get x cubed minus y cubed times x cubed plus y cubed. And that you can apply the difference of cubes formula, get x minus y, x squared plus xy plus y squared. And here you apply the sum of cubes formula. So you get that's fully factored into 4 factors. Whereas here, if you try to apply the difference of cubes formula, you get x squared minus y squared. You would then get x to the 4th plus x squared y squared plus y to the 4th. The first part you clearly recognize as difference of squares. And you would get to here. Now, the thing is, the average pre-calc student is not going to be able to factor that at face value, right? Because you would probably think of that as a quadratic, in which case now I'm going to try to find 2 numbers where when I multiply them, I get the last term. When I add them, I get the middle term. And then you're going to be like, well, the last coefficient is essentially going to be a 1. And the middle coefficient is essentially going to be a 1. So it must be impossible to factor. It's not at all obvious that this thing factors. However, it does. In fact, it factors into these 2 things. But it's going to be hard for you to see that, especially if you're like a typical pre-calc student, right? So the person who goes with the difference of squares first, as opposed to the difference of cubes, will tend to get to the answer a lot easier. Like I didn't have to make any difficult decisions here. Whereas with here, it's like, does that factor? I mean, it's a 4th power. I feel like that should be able to break down. Or, you know, you just might not even know, like you might not even be able to apply any rules, right? So that's kind of what I want to get at, but I want to get to that at a higher level. So now that we know calculus, pretty much all of algebra is a lower level to us, which means at any point, I probably want to be applying some sort of algebra rule before I can apply some sort of calculus rule. And there are going to be times where this is going to make a huge difference. Why did I go through all that? Well, seeing this as a product of functions and trying to jump into the product rule right away, you'll get the right answer, but you'll work harder than you have to. And the potential for mistakes is a lot higher. And chances are, if I give you the answer choices in a multiple choice setting, I would not give you the answer all spread out like you would get it by using the product rule. So what does that mean? So if you see that, what I would first do is think of this as that. And so this is that. So here, first, simplify using algebra, right? X times radical x, why write it like that? That can be written easier. Now, of course, up here, when I had the 3x squared times ln x, I did not have that option. Like, how was I going to simplify that? I couldn't really do anything. Here, though, I could actually simplify this, and you'll now notice I don't even need the product rule anymore. Right? finish off with power rule. Product rule was not needed. Okay, so there are good calculus students and there are great calculus students. And I want all of you to be great calculus students. Being great students also means, yes, the rules tell you what you're allowed to do, but at the same time, you don't just want to indiscriminately apply rules. It takes some discretion. It takes some sort of analysis of the situation, making sure that when we go in, we don't waste our resources, we don't waste our energy. We apply the simplest thing we can first, the simplest thing we can get away with, and then we do it that way. And if we only get harder and ramp up our level of solution if the problem itself is a very difficult type. Now here, there's not much harm, but like I said, here, there was not much harm in just going into the product rule, but there are situations where there it is, and we'll see them later. So if I ask you, what was y equals x radical x, you could have said, okay, y prime is going to be the derivative of the first times the second plus the first times the derivative of the second, right? And so this is just apply a product rule. Now, if you do that and you get that as the answer, and in a multiple choice setting, I'm actually going to put that as the answer, right? Because even when I'm typing out the answers, why would I want to type out all of this when I could just type that, right? I got stuff to do in my time, right? So now you are in the situation where you have something spread out and complicated, and you want to make sure that it's actually equivalent to the simpler thing. Now you're going to have to go through the extra work and simplify this. Well, you'd be like, okay, well, this can simplify into that, goes that, and then this is just radical x. This would then be 1/2 radical x, and then this will be 3/2 radical x, which is that. And trust me, like applying this, having to do this in a test, while rushing can have undesired consequences. Especially with a harder problem. Right. So while it's not dangerous here, you should get into that mindset, right? Like I'm not really just teaching you to pass a test or to just get through some random problems. I'm teaching you how to think mathematically, how to approach a problem, and a very good way to approach any problem is to approach it the simplest way as possible first. Don't like try to kill a fly with a sledgehammer all the time. All you need is a fly swatter or maybe your hand or whatever. Well, not so bad here. You should get into the mindset of applying simpler rules first. Yeah, so that's one of the things where a lot of people get in trouble, believe it or not. So there are a lot of times, I mean, a lot of you who are in this class won't go much farther in math, so you're not going to really see in math where this comes up. But there are a lot of higher level math classes that I've taught where students try to do things directly, and it's so hard and it takes them forever to do it. Whereas when I come in and I just simplify it in the beginning, then it's 2 lines, like it was no big deal. So that's always going to be an issue. It's always going to be a potential. And if it doesn't hurt you here, it'll also probably hurt you in some of your higher level science classes too. So yeah, think simpler. Things should be as simple as possible, but not simpler. I believe that was an Einstein quote, but don't quote me on that being an Einstein quote. But it's a good quote. It's actually it's a pretty smart way to approach life. Yeah, so I would see this, and the average student is going to be like, oh, use the product rule. But yeah, think a little bit harder before you jump into something, and then it'll pay off eventually. Let's move on. Problem 5. So here is a function. We want to differentiate it. So what do we notice here? Well, this is a division of functions. So here we think quotient rule. Since simplifying isn't obvious. You can simplify this, but maybe I'll show you. Right. So you look at a derivative that I give you, and one of the first things you're going to do, could I just kind of simplify this a little bit more before I jump into anything? That's always what you want to think. It's not going to be super obvious how to simplify this, especially if you don't remember a lot of your pre-calc very well, even though you should. It always happens that people never remember enough. So I would just jump into the quotient rule. So we know that the quotient rule says, that one was introduced at the end of last class, so let me remind you. This is f prime g minus fg prime over g squared. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So f prime is 1 times g minus f times g prime, which is also 1, all over g squared. That's going to be the answer. You would tend to want to simplify. So this would be x plus 2 minus x minus 1 over x plus 2 squared. And so that just becomes 1 over x plus 2 squared. Okay. So that's us applying the quotient rule. DTW. Could simplify here, but like in this situation, it wasn't so painfully obvious, so I wouldn't really blame anyone. Well, I mean, I wouldn't blame anyone for not simplifying before going to a problem either way, but you kind of make your life harder by doing that. But you could simplify here actually. So this is a trick that we've learned in pre-calc at some point. Maybe I'll write it out. There's a slightly quicker way, but maybe I'll write it out. One trick to kind of simplify a fraction where nothing factors is to somehow try to get the denominator in the top. So I know my denominator is x plus 2. So can I get an x plus 2 in the top? The answer is yes. What I can do is I can add 2 and subtract 2. So what you realize that this becomes is x plus 2 minus 1 over x plus 2. Now what you can do is this simplifies because you can split the fraction. And so really what you're looking at is this. Not really something I would expect you to notice in a Calc 1 class, but in a Calc 2 class, noticing that that one is actually going to be a lot better for you in some context. But here it's not that crazy. And then at this point, you'd be like, well, y prime is, well, derivative of 1 is 0, and the derivative of this is going to bring the minus 1 down, raise that to the minus 2. Something like this, more useful in Calc 2. I do this one the first way. Yeah, we won't often, unless it's directly clear that you can factor and cancel stuff, like I wouldn't worry about simplifying a fraction. Again, there's nuance to everything. The world isn't always black and white. It's a lot of gray sometimes. Okay. Contrary to what people have you believe, that's true. 6. So here is another one. So now it's a division of functions again. So we want to apply the product rule, yeah? Have to make sure that you guys aren't falling asleep on me. What do we do here? Jump into the product rule?
Quotient.
Quotient rule? Yes?
Yeah, quotient rule.
Quotient rule, because it's a division.
Yeah, I looked at that. You said product rule. I was like, wait, he's trying to mess with that.
Yeah, but maybe I'm trying to mess with you on multiple levels. I would not use the quotient rule here. Do you see why?
Wait, what?
I would not use the quotient rule. What's a nicer way to approach this?
Is that because you can look at it as like 1/3 times x squared?
Because it's 1/3. The denominator is a constant, right? So I could actually, would not use quotient rule here. So let's see what we would do to go back to that lower level rule. I would actually think of this as 1/3 times x squared, and then just differentiate that. Right? I didn't need a quotient rule. Now, let me tell you why here. Even in this problem, which seems very simple, students make a mistake on something like this, like all the time. So let me mention here, it's not wrong, but students often mess up when trying to apply quotient rule.
I actually did use the quotient rule here, and I still got the same answer. So
yes, I'm gonna.
So it technically still works, right?
No, if it's a math rule, so yes, it's going to work.
Okay.
So that's why I said it's not wrong. I started out by saying that, but students often mess up when trying to apply the quotient rule if numerator denominator are constants. And this is just something I've noticed just statistically speaking. Like if most students just mindlessly go into the quotient rule in situations like this, a lot of them get it wrong. I don't know why. Well, I can see why, but I don't know. I don't know why. But I know it happens because I've seen it happen a lot. Like I've been teaching for over 10 years, and I literally teach calculus every single semester I teach. Like, so I've taught a lot of calculus, so I've seen a lot of things. And so here's what would happen. So if I have, say, y equals x squared over 3, and then we start to jump into the quotient rule. Okay, so what is this going to be? The bottom times derivative of the top, right? So you got 3 times x squared minus the top times derivative of the bottom. So that's going to be what? What would that be here?
X squared times 0.
X squared times 0. Now, you didn't get it, so you probably won't realize this, but that's where the mistake often happens. I don't know why, but it happens all the time. Like, so often this happens. Whenever one of the things is a constant in the quotient rule, a lot of students have trouble keeping the quotient rule in their mind as well as keeping the other rules like the derivative of a constant is 0 for whatever reason. I don't really know, but I see it happen all the time. Students will often forget the 0 here. They'd actually recopy the 3 here for whatever reason. And then, of course, you would go put that over 3 squared. So now, yes, you get 3x squared over 3 squared, and you'd cancel this. Sorry, this was supposed to be. See, look at that. Even I'm making mistakes. No one caught me. And then that's 2x over 3. Okay, so it's the right answer, but that is something that you should consider. And sometimes you have to really worry about, and this is something that did I talk about this? I didn't really talk about this in this class, but specificity of practice is super important. So when you are practicing for a test, you should practice by doing tests, by timing yourself. You practice for quizzes, you should practice by doing quizzes, and right? So I know a lot of students get into this habit of, they practice for a test by like redoing their homework or something like that, which is not bad, but it's not the best thing. You're going to realize that there are some times when you're put under pressure and you have to rush through something, you will make mistakes that you wouldn't normally make if you were not rushing. And so this is one of those things that I just think that's what happens. Like when students are just rushing and trying to get through the problem, they make some sort of silly mistake that they normally wouldn't make. Now, of course, to avoid doing that, what you do want to do is you want to practice for a test like you're taking a test, like actually time yourself, put yourself under pressure, because then you'll start to learn what kind of mistakes you make when you're under pressure. And that will have you look out for certain things when you're actually in a test, right? So that's something. And with that being said, everyone has this little slip up somewhere. So you might not have been caught with this mistake, but there's some other mistake out there that if you're rushing, you will get caught with, and you just have to always be aware of that. So you want to practice things in such a way where getting through it as simple as possible by rewriting in a simpler way becomes the natural way you do things, because then you're just less likely to get into a mistake that is going to come up by you doing it the more complicated way, if that makes any sense, right? And you might, sitting at home, not worried about anything, leisurely get through a problem the most complicated way and not make a mistake. But it's a totally different story when you're in a test and Jhevon says 5 minutes left and you start freaking out and start rushing through something. You're in a completely different state of mind, right? You're not thinking clearly. Your anxiety is through the roof, and now you're trying to do this complicated maneuver. You'll actually make a lot more mistakes than you would realize in that situation. And so I would recommend, it's not just a good pro tip in terms of a problem solving standpoint. It's a good to think of things simpler and try to simplify before applying some complicated rule is a good thing from a test taking / accounting for human error standpoint, right? So you're just less likely to mess up if you're doing things the easier way. And so I would recommend that. So yeah, I wouldn't use so I would say here, pro tip. If in the product and quotient rules, if one factor is a constant, don't use these rules. I don't know how to say it. Don't use these rules. So for the product rule, you want to differentiate f times g. If f or g is constant, use the lower level rule. Use the constant factor rule. Don't go through the product rule to differentiate 5 times the square root of x. Why are you doing that? You're wasting time in the best case scenario, and you could get it wrong in the worst case scenario because you're rushing in a test and you're anxious. In the quotient rule, you want to find d dx of f over g. And here's the thing, if g is a constant, all you have to do is leave it alone and differentiate the f, and you're done. Right? So for example, if I had the derivative of x squared over 3, I could literally just leave the 3 alone and differentiate the top, and that's the answer, right? Like I could get to it so much easier conceptually. Why would I do this when I could literally just do that in my head? Like, you understand? Like, even if you get this right, like, why would you put yourself through that, right? So if the denominator is a constant, you just leave it alone and differentiate the numerator, right? You don't need the quotient rule. You're going to get the same answer by taking that strategy. Just differentiate the top, leave the bottom alone. If f is constant, I would say, again, apply a lower level rule. Don't just jump into the quotient rule. Rewrite using laws of exponents. Then apply the constant factor rule. As in the next example. So moving on to example 7, we have this. Now, yes, you could do that with the quotient rule. And if you did it properly, yes, you would get the right answer. Technically, there's nothing wrong with that. However, thinking of this as this instead makes your life so much easier. You don't need the quotient rule. You only need the power rule. You get what I'm saying? Maybe some of you even did this with the quotient rule. Compare what you did to what I just did. Like it was probably shorter doing what I did. And on top of that, psychologically, it was just easier for my brain to get through that whole thing, just by me taking the time to simplify first. I mean, hopefully you guys are seeing that. So I would just rewrite it with laws of exponents. Just bring the numerator up, make the power negative, and then I know, well, the constant is just leave the constant alone, differentiate the function part, the variable part. And so you can get that. You didn't need the quotient rule. Versus you would have y equals 3 over the square root of x, and then you'd have to go into, come on, y, what's wrong with my pencil? It's messing up. Then you'd have to go into y prime equals, well, the bottom times the derivative of the top, which is 0, but a lot of students would actually mess up there. Minus the top times the derivative of the bottom over the bottom squared. And then you're going to realize, okay, so that's 3 minus 3 over 2 times x to the minus half, I want to say. Over just x. Now I'm going to have to worry about simplifying this part. So then I'm going to have minus 3 over 2 times x to the minus 1/2 minus 1. And then I get to that answer where I could have gotten that, like, both conceptually and by writing things out, I could have gotten there so much easier, right? And again, this is a super simple problem. Like on a test, you're not going to be dealing with problems of this level, right? But it's even clear with this simpler example, how much easier, just in terms of time, in terms of effort, in terms of just psychologically, like it's so much easier, like, to get through this. You know, you're going through a test and, you know, it's been like an hour and 25 minutes and you're on the last problem. Really, you don't want to put your brain through that. You just don't. It's just cruel at some point. You just want to just like, all right, buddy, you did good today. let's finish this off easier. Let's finish this off strong. And that's how you would do it. So I actually would not use the quotient rule here, even though with the division, it kind of screams quotient rule. At that point, just understand that that's your brain that doesn't deliberate very much, just trying to freak out, and try to just let's calm down first. Let's think for a couple seconds and see, is there a better way? It's always good to stop and think for a couple seconds. 8. Okay, how do we differentiate this?
Bring the numerator up and do product rule.
Okay, and what rule now?
Oh, wait, no, just exponent.
Yeah, you just.
Yeah, just exponent. Sorry, not product.
Yeah, you don't. My thing is messing. My pen is messing up. Yeah, didn't need the quotient rule. You bring it up and it's like, oh, it's just the power rule. Leave the 4 alone and just do the power rule. Okay, 9. Y equals, I don't know what's going on here. Maybe I have to restart this.
On like a test, could we leave the answer like that, or would you want us to like bring the X like back down?
Oh, this is okay.
Okay. Because the test
Yeah,
is
that whole thing about, oh, it's bad to have a negative power or have a radical in the denominator. That's not true. That's something we tell pre-calc kids just to scare them and keep them honest. When you get to calculus and above, no one cares. So it's okay to leave answer like okay to leave negative powers or radicals in the denominator. Of your answer in general. Now, there are a couple of reasons why, and you know, I know that's ultimately where this question is coming from. Some of you are probably traumatized back in algebra and pre-calc class that whenever you wrote an answer with like a negative exponent or like a radical in denominator, they said you should have rationalized or you should have brought it down, and you know you get punished for that. There are a couple of reasons for that. One is in pre-calc, this is the benevolent reason. And then I'm going to tell you another reason, which is just completely practical and selfish from the point of view of the person giving you the problem. So one reason is that when you're just learning the rules, the more you practice them, the better. And so forcing you to rewrite things a certain way kind of forces your brain to get used to the manipulation of knowing, oh, negative power means I can bring it in the bottom. Oh, a radical in denominator means rationalizing is a thing. Like it just constantly reinforces that. So you get way more practice on mathematical manipulation by someone just requiring you to make sure your answer is in a certain form. Because chances are, if you get the answer one way, it takes some sort of mathematical manipulation to get it in the form that they want. And there's benefit to that mathematical manipulation because now you're just getting yourself used to applying the rules, right? So that's one reason why they tell you that, not because it's any more correct, because it isn't. Another reason that they would tell you that is typeface. It is easier for them to type something without radicals in the denominator or a bunch of negative powers all over the place, really. So when you look in the back of a textbook, chances are the answer is going to be written in a form where there are no negative powers and there are no radicals in the denominator. And so teachers just tell you, always write your answer in that form. So when you look at the answer in the back of the book, you can just right away know. So yeah, sometimes it's harder to typeface and type math out. And so you would tend to see things typed out a certain way in the back of a textbook, and that would tend to fall in line with the display requirements that someone would give you in a pre-calc class. So that's the real reason. Those are the real reasons. But it's not like anything is one is more correct than the other, because it's not. As well as that's the only thing I would say here as well, because in the event that I'm giving you a multiple choice question, it just might be the case that I would write the answer in such that it only uses positive powers. And I would expect you to know, oh, if I get this answer and I look at the answer choices and I see this answer, I should know that those are the same, right? So, but if this is given as an answer choice, you should know they're the same. You should know it is the same answer. Okay. So if you are showing your work for the test and in your final answer, you wrote it like this, but that wasn't answer choice and you check, I would still expect you to click this box, the box that has this in it. And you wouldn't really have to justify to me why you clicked that box. I would just assume you realize that these two things are the same. So in general, there's no taboo way to write it down. You can write in any notation you want as long as it's correct. The only difference is you should be aware that if I give you an answer choice or you're practicing from the textbook and you look in the back of the textbook for at the answers, it might be written in a different form than you had it in, and you should recognize it. So that was a very long-winded answer, but that's the answer. Here, though, in this one, can't really simplify. What are we going to do? So in this case, I would jump into quotient rule. But it's not because I did not consider not using it. There's pretty much one derivative rule where I can say this idea does not apply, and that's the chain rule. You can literally apply the chain rule all the time, and it will never be way more complicated than it has to be. Because if you use the chain rule when you don't have to, literally the only thing that happens is you multiply by a 1. It never actually gets complicated. So I would say, if you're not sure about the chain rule, it's okay. Just use it literally all the time. You can always use the chain rule. You are not in any danger. Use it anytime. When you're using like the product rule and the quotient rule, there are little bits of nuances here because they themselves are large. They can get large. And so you don't want to go through a lot of complicated calculations if you don't have to. In this case, though, I would rather do the quotient rule. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That's probably something I should write out though first. Hold on. Over the bottom squared. Which, by the way, I want to point out, this is not e to the x squared. This is e to the 2x. Very common mistake, especially when students are in a test. When they see e to the x and then all squared, they think e to the x squared. This is not true. Laws of exponents. You multiply the powers when you raise one power to another power. Okay. So then, yeah, you'd have e to the x so something like 1 over x minus ln x over e to the x. Or you could do something like multiply and divide by x. 30 to 20, right? And you would get the answer as 1 minus x ln x over x e to the x. Which chances are, in a multiple choice setting, that's probably how I would type the answer. Because having to type out a fraction inside of a fraction is actually more difficult than I would like it to be if I'm typing out a bunch of answers. That's the truth. So like the code I would have to write to type this out is harder than the code I would have to write to type this out. Because I use LaTeX when I'm writing up the test. So it's not like I'm using templates and dragging and dropping or anything like that. I type out all the questions.
Wait, quick question. So is the test then going to be multiple choice online?
No. There will be multiple choice problems, but there will be, you have to justify your work anyway.
So it'll be like handwritten and we have to like upload pictures?
Right,
Okay.
exactly.
Got it.
Yeah. And in fact, right now, what I'm going to do is I'm going to post the test that I gave last semester in the fall. I'll post test 1, and you guys can actually go through and practice that. So you'll see what your test is going to roughly look like. I mean, I'll change some of the problems, but you'll see what your test would roughly look like. But essentially, it's going to be like, it's almost going to be like a quiz because I'm going to ask you questions and then I might give you some answer choices. But then you might see something like, there'll be a direction to say, show all your work for this problem. And then at the bottom of it, it's going to have an upload button for you to click on it and upload it. And so what would happen is, I would say you should log into Gradescope from 2 places if possible. One is like from your cell phone, and then another from the computer. You can read things off the computer screen, but when you're submitting your answers, you do it from your cell phone. Because what you can do right there is the moment you write something, you can just take a picture with your phone and upload it from your phone while you're moving on to the next problem. Because that's kind of how it's going to be.
Okay, that makes sense.
But yeah, so I will, because for tests I want to be able, and I guess this is going to be the last example. We'll do the rest on Monday. So the test is during class time on Thursday. So you won't be seeing me on Thursday technically. So we'll finish up the rest on Monday. But yeah, just to talk a little bit more about the test, it's going to look like a quiz, but with the added thing that there's going to be upload buttons on a lot of the problems where you're going to have to click and upload a picture. And there are going to be instructions. So I'll give you the mock test. The instructions will be exactly the same as the real test. So once you know those, it'll be fine. I will leave the mock test. It will be timed when you enter it, but I will leave it open until like Wednesday at midnight. So you would have to take the test, which I believe is going to be 1 hour and 15 minutes long, plus 15 minutes upload time. So you probably want, you would want to take the mock test starting no later than like 10:30 on Wednesday night. And then after that, you'll know what it would feel like to do the actual test. So in fact, I am going to do that now. I'll just add the test 1 from last semester to your Gradescope. I'll leave it open for a few days so that if you want to go and study, and like I said, practice, being specific in how you practice is very important. So I wouldn't just kind of approach the mock test willy-nilly. I would like pretend it's the real test, pretend it's the real deal. You want to practice with that mindset. Like, I'm going to put a clock. I'm not going to use a calculator. I'm not going to be listening to music. I'm not going to be looking up stuff while I'm doing it. You're gonna study. You take today, take tomorrow. You actually study, learn all the rules, do your practice, do your homework, and then take the mock test. Pretend it's a real test, right? Don't do it until you have the time to do the full test in one sitting, and then you just do it, right? Because that's when you're going to start to realize, oh man, I made that mistake. Like, that wasn't a mistake, I made it during homework, and things of that sort. And you're going to kind of be able to judge how much time it took you. Did I run out of time? Was I quick enough? Was I right? And you'll be able to use that as data for how you want to approach the actual test. We will stop there. I might actually get farther in the other class, farther into these examples in the other class by Wednesday. So you might want to watch those lectures for extra practice if you want, but we'll stop there for now. So thank you for your time and attention. Apologies for the technical difficulties today, but we will end right there. I will post the mock test starting in a few minutes, but I would again recommend that you actually try to study before taking it. Don't just open it right now. Actually take a day or two, study for real, and then take it for real. But I'll open it as of like 10 minutes from now. Okay, that being said, enjoy the rest of your day. I will see you guys next week in the next one.